All right, let's solve some linear inequalities in one variable. This is directly from my 2.2 Hawks problems. These may look very much like yours. This is what mine looked like. It says, consider the following compound inequality. Compound inequality is what I called earlier a double inequality. Same idea, 1, 2, 3 parts with two different inequality symbols. My strategy, of course, is to get the variable by itself. So here we go. This is the part, the middle part involves the variable. Let's get the z by itself. First, get rid of this plus. Get rid of the 6. Add 6 everywhere. Divide all parts by 4. So z, it turns out, is between 0 and 9, including 9. It says solve the inequality and express your answer in, here it is, interval notation. That's where I use the parentheses or the brackets. This is from 0 to 9. The 0 does not have an equal sign, it gets parentheses. The 9 does have an equal sign, it gets brackets. So here's my answer according to what Hawks asked. Now it says graph the solution set. All right. Zero to 9. 9 has a bracket. 0 has parentheses. Everything in between is the graph. And there we have it. 1 down, 11 to go. It says consider the following linear inequality. A lot of glitches here, sorry about that. Let's see. I have a decimal here, no big deal. We can work with that. Now you might recall that I said in solving an inequality, it's best to get the variable on the left. That way when you have a final statement, it'll say something like y is greater than something, y is less than something. Y will be the subject of my mathematical sentence. So I'm going to subtract, get rid of the 5 y's on the right. This is my y side. I don't need a negative 8.4, so add 8.4. Y is less than, this turns out to be 1.4. Express in interval notation. You know, one thing I've discovered, if you have a difficulty finding the interval or expressing it in interval notation, if you graph it first, the graph is a really good visual reminder of what the interval notation should be like. So if we graph the thing, which shouldn't be much of a problem, let's see if I can find it good, there we go. I need 1.4. And y is everything less than 1.4, that way. So here's a graph. What do I have here at the ending marker? There's no equal sign, so parentheses. This gives me a good idea about how to do the interval notation. It's from negative infinity all the way to 1.4. So negative infinity to 1.4. Infinity symbols always get parentheses. 1.4 has a parenthesis, so I'll have parentheses there as well. Why parentheses? No equal to sign. So there we have it. Interval notation, the graph. All right, this feller's got 4 parts. Consider the following inequality problem. Hey, it's an or problem, right? This or that. Step 1, solve the first inequality and express in interval notation. So we're just giving this first guy some attention. Obviously, I'm going to do some distributive. I get negative 5y plus 20. Y is on the left. That's where they're supposed to be. Let's get rid of this minus 20. Here's where I remember the very distinct difference between solving an inequality and solving an equation. When I divide both sides by a negative, oh yeah, I remember now, my inequality symbol switches. So y is now greater than or equal to negative 2. Interval notation, greater than or equal to negative 2. It's going to look like this. Greater than negative 2 or equal to. So there's the graph of it. That gives me a good idea of what my interval notation is going to look like. It's from negative 2 with parentheses all the way to infinity. And infinity always gets parentheses. So here's my first feller in interval notation. Here's my second one. That's the second part of what I need to do. I think I need to subtract 18. And I get y is less than 2. Here's what it looks like graphically. Less than 2 is that way. No equal to sign, so I get parentheses. This helps me see what my interval notation is going to look like. It's from negative infinity all the way to 2. And infinity symbols always get parentheses, and the 2 has parentheses as well. So here's my second interval notation. Now, using your answers from the previous steps, solve the overall inequality problem and express your answer in interval notation. Use decimal form for numerical values. Now, from my perspective, it's going to be easier for us to graph the thing first before we see what the combined solution set is. So let's go ahead and graph it. Remember, this is an or statement, so any place there's a mark is part of my solution set. The and is where they overlap. Remember, where they intersect? The or is any place there's a mark. So my first one is going to be from negative 2 all the way to the right. Negative 2 with bracket all the way to the right. So there's my first inequality. On the same graph, I'm going to graph the second inequality, and that's everything less than 2. So from negative infinity all the way to 2. Negative infinity all the way to 2. Hey, look what's marked. Every single part of the number line is marked. So there's the graph right there. And that means that the solution set in interval notation is going to be from negative infinity to positive infinity. We say it's all real numbers, but in interval notation, it looks like negative infinity all the way to the left to all the way to the right. All right. Number 4, got another double inequality or compound inequality. First of all, it says solve. And notice the characteristic here. I have a fraction. And you remember the steps, I'm assuming. If not, you have notes. Step number 1, find the LCM of denominators. 8, 4, and 8. The LCM is 8. The smallest number that these will divide into evenly is 8. So my second step is multiply each part or each term by 8. So since these are fractions, I'm going to put the 8 over 1. Remember, I do not want to multiply the tops, the numerators. I want to let my denominators cancel. So let's let the let's let the denominators cancel. 8 will go into 8 one time. 4 will go into 8 two times. 8 will go into 8 one time. So I got 1 times 16. Hey, look, no more fractions. 2 times n plus 9. 1 times 22. So a little distributive, 2 times n plus 9. I want to get the n by itself, so I got to get the 2n by itself first, so get rid of the 18 on all 3 parts. Whatever you do to one part, you got to do to all 3. Divide by 2, all 3 parts. And I got it. Negative 1 is less than n is less than 2. Better way to say it is n is anything in between negative 1 and 2. Interval notation. So from negative 1 to 2, no equal to signs, so I got parentheses. There it is. Graph the thing, no big deal. It's everything from negative 1 to 2. Since there are parentheses here, there will be parentheses here. Endpoints are not included. Hey, this is going along fine. Number 5. Okay, we got a word problem involving inequalities. To qualify for gold status at Awesome Airlines, one must fly at least 7,000 miles and less than 16,800 miles each year. In other words, at least that, less than that. Greg takes a 350-mile round trip to visit his grandparents. How many times does Greg need to visit his parents each year to attain gold status? Express your answer in interval notation. All right. So to get gold status is somewhere between 7,000 and 16,800, right? It says at least 7,000. Could it be 7,000? Is 7,000 included with at least? Yes. 7,000 is included. So that's this concept. And less than 16,800. So is 16,800 included? If I do 16,800, am I still gold status? No, it has to be less than, so this is not included. Now, Greg takes a 350-mile trip to visit his parents. How many trips is that? How many trips is that? Well, I think if we divided this by 350 and divided this by 350, we would find out how many trips he has to take and how many less than how many he has to take. So let's divide 7,000. Divide 350. That turns out to be 20, so he has to take at least 20 trips. That's got brackets, at least 20 or more. And now let's do 16.8. Divide 350. That's 48 trips. Has to be less than that, so it can't be 48. It has to be less than 48. So somewhere from 20 to 48, including 20. Express your answer in interval notation. There it is. There's my answer. So we did the miles he had to cover to be in gold status. We recognize that each trip was 350 miles. So the miles divided by the miles per trip gives us the number of trips. 20 trips at least, less than 48. All right. Compound inequality again. Hey, it's a fraction. That means first step, find the LCM of 6 and 3, going to be 6. The least common, the smallest number that 6 and 3 will divide into evenly is 6. Step 2, multiply all parts by 6. Since the fractions, I'm going to put 6 over 1. Just to help me remember how to multiply a fraction by a whole number. Remember, don't multiply the tops. Let the denominators cancel. 3 into 6 twice. 6 into 6 once. So 1 times 10. I'm going to go ahead and multiply 2 times x plus 3 because it's pretty straightforward. That's 2x plus 6. 1 times 23. Again, get the x by itself. Let's get rid of 6. And your problems that you work in Hawk should look a whole lot like this. Maybe some denominators or some of the numerators are changed, but it's very, very similar. So I get 4 is less than 2x. It's less than 17. Divide by 2 and I got it. I get 2 is less than x is less than 17 halves. Interval notation. Oh, by the way, it says use decimal form for numerical values. So 17 over 2, what's that going to be? 8.5. So I need to use a decimal for that. So x is somewhere between 2 and 8.5. Oh, did it tell me to graph it? It did on the next page. It tells me to graph it. So I'm going to be graphing somewhere between 2 and 8.5. And as you move your little cursor, your little marker on your graph, it'll go down by tenths. 8.7, 8.6, 8.5. And I want everything in between there. And my ending markers are going to be, no equal signs. So my ending markers are going to be parentheses, which shows me what my interval should look like, from 2 to 8.5, from 2 to 8.5 with parentheses. All right. The perimeter of a square, and you know what that is, that's the distance around it. The perimeter of a square must be greater than 102, but less than 138. Let me go ahead and write that down. Greater than means it's not included, so it's a parentheses. Less than means it's not included. So my perimeter has to be somewhere between 102 and 138. Find the range of possible side lengths that satisfy these conditions. Hint, the perimeter of a square is given by perimeter equals 4 times s, where s represents the length of a side. All right, these are perimeters. If I want to find the sides, then I'm going to simply have to divide the perimeter by 4. Watch. Perimeter equals 4 times s. If I want to solve this for s, side equals the perimeter divided by 4. So as I divide these perimeters by 4, I'm going to get the lengths of the sides. So 102 divide 4 is 25.5. 138 divide 4 is 34.5. So the length of my sides for these squares have to be between 25.5 and 34.5. Since it said greater than, and since it said less than, I do not have equal to signs here. So there's my solution. Again, interval notation. They like that interval notation here at Hawks. 7 out of 11 down. Let's go to number 8. Consider the following inequality problem. Hey, look at this. Something and something. When we get down here to our graph, it's going to be where the two things overlap. Keep that in mind. This is an and relationship. All right, let's solve the first one. -5, t minus 1, less than or equal to 50. A little distributive. -5 times -1 plus 5. Subtract 5 from both sides. Here's where I need to remember that if I divide an inequality by a negative, which I need to do here, then my inequality symbol switches. So t is greater than or equal to -9. So solve, express in interval notation. So greater than or equal to -9. If I was going to draw the graph, greater than or equal to, so the -9 gets a bracket, and means everything to the right. And if I put that in interval notation, it's going to be bracket at -9, all the way to the right, we say that's to infinity, and infinity always gets parentheses. There's the first inequality. Second inequality, 4 minus t is less than 8. Keep the t's on the left side. Negative t is less than 4. Divide both sides by, there it is, negative. I'll switch my inequality. T is greater than negative 4. So there's the solution, but they wanted an interval notation. If I were to graph it, t is greater than negative 4. No equal to sign, so I get parentheses here. Greater than is to the right. There's a picture of it. Now I want it in interval notation. So I'm going to do all the good stuff. Start with parentheses at negative 4 all the way to infinity. Always parentheses with infinity. It says use your answers up here to solve the overall inequality and express your answer in interval notation. This and that. In order to see what this is going to look like, let's graph it first. Remember when I graph an and relationship, if I have two different colors or two different ways to express my graphs, it's going to be where they overlap. So let's see. First of all, is going to be greater than negative 9. Here's negative 9. Greater than that, I'll use black for this. This is everything greater than negative 9. Now I'm going to graph everything greater than negative 4. So it's from negative 4 on. I will use my lovely pink marker. Negative 4 to the right. All right. I want to look for the overlap. So the overlap, the place where these two graphs overlap, is obviously from negative 4 to the right. And remember, just like the problem we worked in our notes, negative 4 is not included in my pink graph, so it's not in both. So if it's not in both, it's not included in the solution set. So it's from negative 4 on, not including negative 4. So there's a picture of my overall inequality. It says solve the overall inequality problem, express your answer in interval notation, use decimal form for numerical values. So the overall inequality is this and that. It seems I should have written in this last or, where was that or? Pardon me a second. Back to number 3. Back to number 3. I should have written this, the or, as that or that. So it's going to be negative 2 to infinity, parentheses, or negative infinity to 2. So this is how you write it in its interval expression. This is what it turns out to be, but this is how you write it in its interval expression. An OR statement. Sorry about that. So let's now do the AND statement. So it's this and that. And some of you probably are ahead of me. If OR was the union, AND is the intersection. This is the intersection, the overlap of the two solutions. This and that. So another way to read this symbol is AND. So we solved one, we solved the other, we put them together in an AND relationship. To graph an AND relationship, I put them on the same graph and see where they overlap. To graph an OR, I put them on the same graph, and anywhere there's a mark, that's part of my solution. All right. Number 9. In a class in which the final course grade depends entirely on the average of 4 equally weighted 100-point tests, Brad has scored 83, 94, and 77 on the first 3 tests. What range of scores on the 4th test will give Brad a B for the semester? An average between 80 and 89, here's a key word, inclusive. Inclusive means include your 2 endpoints. So if I were to draw a picture in interval notation of what Brad needs to get, it is between 80 and 89 inclusive. Because it said inclusive, I include the 2 points. If it didn't say inclusive, just between 80 and 89, that would be parentheses. Between does not typically include the 2 endpoints. With the word inclusive added, it does. So this needs to be his average. He's got 4 tests, each at 100 points each. So the way you get an average is the total points divided by the number of, in this case, tests. So his average of 80 is going to be something divided by 4. If this guy's going to have if Brad's going to have an 80 average, then his grade total needs to be 4 times that. So I'm going to multiply each of these averages by 4 to get the grade total that he's going to need. So 4 times 8 is 320. And 436. 56. So if his average is 80 to 89, his total before he divide it by 4 is going to be either 320 or between 320 and 356. This is the average. These are the points he's got to get his B, somewhere between 80 and 89. All right, so far he's got this much for his total. Let's see what this much is. That's 83 plus 94 plus 77. That is 254 points. So he's already got 254 points. Let's see how many he needs to get still to get these point totals. He needs 320 points to get an 80. He's already got 254. How many more does he need? I don't know. Let's subtract 254 and find out. Let's see, that's 46, 40, 66. He needs to get at least a 66 here. 254 from 356. That's going to give him 102. So he's got to make somewhere between 66 and 102. But wait a minute. The tests are only 100 points, so I'm not going to put 102. That's unrealistic. I'm going to say he's got to go from 66 to 100 to get his B. He can only make 100, so putting 102 is unrealistic. So let's see. Assume that the test scores have a non-negative value. Express your answer in interval notation. There's my answer in interval notation. A good thing about these problems is you will not see one like this on your test. You will see one like this on your particular Hawks assignment, but it's doable, and you won't see one like this on your test. All right, solve the following absolute value inequality. Express your answer in interval notation. All right, please note what this is. Let me see if I can find the notes on that we took earlier. This is an absolute value is greater than. Absolute value is greater than a number. It's going to be this second example. It translates to two inequalities with an OR relationship. So let's keep that in mind. Hey, remember solving an absolute value? Same as solving an inequality. First step, isolate the absolute value. Get it by itself. Right now it's being multiplied by a 9. So let's divide both sides by 9. And I get absolute value of 2 minus x is greater than negative 18 divided by 9 is negative 2. Wait a minute. This is looking like one of those special instances. Anybody recognize this? The exceptions involving absolute value, they involve an absolute value and a negative number. Check this out, an absolute value and a negative number. Hey, how often does this happen? How often is an absolute value greater than a negative number? An absolute value greater than a negative number? That always happens. And since this always happens, I can conclude that my solution set is all real numbers. Everything works. So my solution set here, everything works, all real numbers. But it says express your answer in interval notation. So the way we say all real numbers in interval notation is from negative infinity to infinity. That's all real numbers in interval notation. And we always use parentheses with our infinity symbols. Hey, so this turned out not to be a problem to work, but a problem to observe. Anytime I have absolute value and a negative number, it's not going to be a problem to work. It's going to be one of my exceptions to recognize. All right, well, that worked pretty quickly, pretty nicely. Let's try one more. Consider the following absolute value inequality. Hey, check this out. Absolute value is less than. First of all, solve the inequality. Step number 1, isolate the absolute value. Right now it's being multiplied by a 3. So I'm going to divide both sides by 3. Divided by 3, 5. You remember how to simplify, how to translate an absolute value as less than a number? You translate it into a double inequality. Or what Hawks is calling a compound inequality. And whatever's in the absolute value goes in the middle. That's y plus 4. And it is surrounded by, with the same inequality symbol that I have here, it is surrounded by this number and its opposite. Remember, the larger number always points toward the smaller number. All right, get y by itself, minus 4, minus 4, minus 4. There's my picture, there's my solution. They wanted an interval notation. What I have here is my y is in between -9 and 1, including -9 and 1. So it's in between -9 and 1, including means I use the brackets. Graph the solution set, no big deal. -9 and 1. Y is in between -9 and 1. Brackets in my interval, so brackets on my number line. All right, that's it. 11 out of 11. Stay faithful. Keep working. Stuff is due this week.